Hello, welcome to yet another video of Cornerstones of Math, and today we will solve the following problem. Consider a grid of roads as shown in the figure. At this point, some of you might think, this is the famous find the number of shortest path problem, right? Well, no, because in here the rules are slightly different. Here, you want to move from point A to point B by following set of rules. The first rule is that you can move in any direction on the road except west, and the second rule is that you cannot go through the same road twice. So under these rules, problem A is how many different paths can you take? And the problem B is how many different paths can you take if you cannot cross points C and D? Alright, so we're going to solve this problem, and the first step of every problem solving is having a clear understanding of rules given in the problem. So let us take a closer look at rules once again. Especially this part of the rules, you are not allowed to move west. This means that whatever path you may take, that path always involves moving east exactly 4 times. Therefore, we can do the counting like this. First, let us divide the horizontal path in our grid into 4 sections, denoted as S1, S2, S3, and S4. In each section, there are 4 horizontal path segments at different y positions, denoted as A, B, C, and D. Then, the specific path from point A to point B can be determined if the horizontal paths are determined for each section, because once the horizontal paths are determined, we can simply connect these horizontal paths by creating vertical paths that either go north or south, since both north and south directions are allowed. For example, this path right here showing on the screen is determined by selecting horizontal path B, D, C, and D for sections S1, S2, S3, and S4 respectively. Since there are 4 horizontal paths for each section, namely A, B, C, and D, the answer to the first problem, how many different paths can you take, is 4 times 4 times 4 times 4, which is 256. We can also think of it in this way. Here, the purpose of this vertical path, denoted as V1, V2, V3, V4, V5, is merely connecting different horizontal path segments. So we can think of these vertical lines as points V1, V2, V3, V4, and V5, as shown in the right figure, connected by 4 horizontal paths A, B, C, and D. And you can easily find out that the number of paths from A to B is 4 times 4 times 4 times 4, which is 256. And now the second problem, the number of paths if you cannot cross points C and D. Here, at the starting point A, we have 2 choices, going north or going east. So let us introduce these 2 points E and F and divide into 2 cases, AEB routes and AFB routes. Case 1, AEB routes. In this case, for section S1, we cannot pick path A because we have already moved to point E. So that leaves us only 3 choices, path B, C, or D. For section S2, we also cannot choose path A because taking path A makes us cross point C. So we also have 3 choices for this section. For section S3, we can choose any path, so we have 4 choices here. Finally, for section S4, we cannot choose path C because that makes us cross another forbidden point D. So we have 3 choices. Therefore, we have 3 times 3 times 4 times 3, which is 108 different paths. And now for case 2, AFB routes. Here for section S1, we can choose only path A because we have to get to point F, so we only have 1 choice. And since we cannot go to point C, we can only choose path A for section 2 as well. So only 1 choice for section S2. For section S3, we have no limitations, so we have 4 choices. And for section S4, we cannot choose path C, so we have 3 choices. Therefore, in this case, we have 1 times 1 times 4 times 3, which is 12 different paths. Therefore, combining these two cases, the number of ways possible is 108 plus 12, which is 120. And that was all for today's video. Thank you all for watching, and if you enjoyed this video, please give it a like and also subscribe to my channel, and I will see you in another video.